In this class, we will discuss one or two problems on projectile motion. In the earlier class, I had explained the concepts and also I had derived some of the equations for projectile motion on a horizontal plane. So here, let us recall the formula which we have derived in the earlier class. In the case of a projectile motion on a horizontal plane, like this, the AB, this x-axis represents the horizontal plane. If you take any point on the projectile, that is on the trajectory, this is the equation of a parabola. This is the equation of the parabola. You take any point P, x comma y, treating this A as the origin. So this is the equation we are going to get for this trajectory. Y is equal to x tan alpha minus dx square by 2y square 2u square into 1 plus tan square alpha. So in the case of projectile motion, both horizontal motion and vertical motion of the projectile will be considered. And x is equal to u cos alpha into t, because u cos alpha is the horizontal component of the velocity u. And the maximum height reached by the projectile h is given by u square sin square alpha by 2g. And the time of flight, that is to travel from A to B, this is called as the time of flight, traveling from A to B, this is given by 2u sin alpha by g. And the range, horizontal range of the projectile, which is the distance along the x-axis from the first point to last point, that is given by r is equal to u square sin 2 alpha by g. And the maximum range always occurs when alpha is 45 degrees. There is the angle of projection when it is 45 degrees, you will get the maximum range. And this is the expression u square by g is the expression for maximum range. And also, for a given value of r, so this is the, suppose let us say, this is the given value of r maximum is this. For a given value of r, you will be having two values of angle of projection. So that is alpha 1 and alpha 2. Which is given by 45 plus theta and 45 minus theta, where theta can be determined for a given value of r. Now, these are the equations which govern the problems on projectile motion on horizontal plane. Now, let us discuss one or two problems on that. The first problem is a body is projected at such an angle that the horizontal range is 3 times. Horizontal range, that is r, is 3 times the maximum height, that is h. Find the angle of projection, that is alpha we have to find out. Of course, this is a simple problem. You know the formula to find the horizontal range as well as the maximum height. Now, according to that statement, horizontal range is 3 times, that is r is equal to 3 times h. This is what we have given. So, we have to find out the angle alpha. So, r is given by u square sin 2 alpha by g. That I will write u square sin 2 alpha by g, the expression for r is equal to 3 times h is given by u square sin square alpha by 2g. U square sin square alpha by 2g. So this is the given equation, given relationship between r and h. So now if you simplify this, g will get cancelled here, u square will get cancelled here. So you will be left with the sin 2 alpha is equal to 3 sin square alpha. So sin 2 alpha can be written as 2 sin alpha cos alpha, and that is equal to 3 sin square alpha. 1 sin square alpha you can cancel. So 2 cos alpha is equal to 3 sin alpha, or I can write sin alpha divided by cos alpha is equal to 2 divided by 3. So that is tan alpha is equal to 2 divided by 3. So therefore the value of alpha will be equal to tan inverse of 2 by 3, which you can take it as, so I write tan inverse of 2 divided by 3, which is 33.69 degrees. So 33.69 degrees. So this is the angle of projection. So if you project the object with this angle, then the horizontal range will be equal to 3 times the maximum height. So of course, it's a very simple direct substitution problem. So just by knowing the relationship between the R and H, you can get the value. So now, of course, 3 by 2. So I think it is 3 sin square alpha. So 3 sin alpha, 2 cos alpha is equal to 3 sin alpha. So sin alpha by cos alpha is equal to 3 by it is 2 by 0 only. So 33.69 degrees. Okay, it is. I think this 2 will be there, So 2 into is equal to 3 sin square alpha. Is it correct? Please take it once again. U square sin 2 alpha by g is equal to 3 times u square sin square alpha by 2g. Okay. So since please take the expressions. U square sin 2 alpha by g is equal to 3 times u square sin square alpha by g. Okay, 3 by 2 and the g will get cancelled. Sin 2 alpha is equal to 3 by 2 sin square, 3 by 2 sin alpha. So I can 2 sin alpha cos alpha is equal to 3 sin square alpha. 3 sin alpha is equal to 2 cos alpha is equal to 3 alpha. Sin alpha by cos alpha is equal to 2 by 3. So tan alpha is equal to 2 by 0. Alpha is 33.69 degrees. So next problem is, so we will I think this 2, this 2 I have not taken. That's what. So this becomes 2 sin 2 alpha, that means it is 4. Yeah, so then this becomes 4 by 3, 1.33. So 4 by 3. That's what I need. Okay, now the answer will be tan inverse of 4 by 3. Please make that change. So you should be very careful. You got doubts there, that's why I did it. So 4 divided by 3, which is 53.13. 53.13 degrees. So this is the angle of projection of the object. Next, second problem, slightly different. So in this problem, what he has given is, a projectile is aimed at a target on the horizontal plane and falls 12 meters short when the angle of projection is 15 degrees. See, here the thing is, a projectile is fired like this. So this is y-axis, this is x-axis, this is the horizontal plane, starting point is this. It is projected in such a way that, of course, it is targeted at some point, but it cannot reach the exact point. So let us say B is the targeted point, so that the distance is S. This is the target, but when it is projected at an angle of 15 degrees, it falls on the ground at a distance 12 meters short. So like this, so 12 meters short. So this distance is 12 meters. When it is projected at an angle of 15 degrees, it falls here. So this angle is 15 degrees. Okay, so understand the problem here. And while it overshots by 24 meters when the angle is 45 degrees. Suppose if the angle is 45 degree, it overshots means it will fall away from this B at a distance of 24 meters. So actually the target is B, but when it is projected at an angle of 15 degrees, it falls at a shorter distance by 12 meter, and when it is projected at 45 degrees, this is 45 degrees, it falls away from the target by 24 meters. So this is the question here. Now the problem is, find the angle of projection to hit the mark. That means, suppose if at all we have to hit this ball, something like this. So we have to hit the mark like this. What should be the angle of projection? This angle we have to find out. So here, of course, the angle of projection, if it is 15 degree, it falls short by 12 meters. If the angle of projection is 45 degrees, it overshots by 24 meters from the target. Therefore, what is the angle with which that target that object has to be projected to hit the target at B exactly. So that means now, suppose if I take this S as the horizontal range, exact horizontal range to the target, so this distance becomes S minus 12. This becomes S minus 12, whereas from here to here, so that is this is C, D, let us say, AC becomes S minus 12, whereas AD becomes S plus 24. So that means you know the two values of range and two values of angle of projection. So like this. So suppose if alpha is equal to 15 degrees, then R is equal to S minus 12. This is the distance. If alpha is equal to 45 degrees, R is equal to S plus 24. It overshadows by 24 meters, then alpha is 45 degrees. Now the question is, what is the value of alpha for S, R is equal to S? So this is the question. So when R is equal to S, what is the angle? Alpha. So very simple problem here also. The two equations you are going to get here. Of course we have to use this equation. Please note that we have to use this equation for range. So U square sin 2 alpha by G. So we have this equation R is equal to U square sin 2 alpha by G. So this equation we have to substitute two times. One for this, one for this. You know the value of alpha 15 degree. So for the first case, alpha 15 degrees we substitute R is S minus 12. So S minus 12 is equal to U square. We don't know the value of U. So U square sin 2 alpha means sin 2 into 15 degrees, that is sin 30 degrees divided by G. This is one equation. For the second case, when same equation we use for the second condition, so S plus 24 will be equal to U square. U remains same, but alpha is different. Alpha is 45 degrees, sin 2 alpha means it is 90 degrees divided by G. So these are the two equations we get by substituting those. Now here there are two unknowns, U and S. They are the unknowns. So you can solve easily those two equations. Now what you can do here is S minus 1, S plus 24 means you can subtract one from the other. So what I will do is I will subtract equation 1 from 2. So LHS minus LHS, S plus 1 minus of S minus 12 means it becomes 36. See, please note here, S and S will get cancelled. This 24 plus 24 it becomes. When you subtract, so 36 is equal to, here U square by G you can take common. U square by G you can take common. Sin 90 minus sin 30. That is 1 minus sin 90 is 1. So 1 minus sin 30. Sin 30 of course it is half. So from this you can easily get the value of U square. So 36G is equal to U square into 1 minus 0.5 is 0.5. Therefore U is equal to square root of 36 times G is 9.81 divided by 0.5. So U square will be without square root. U will be with square root. So therefore the value of U becomes now root of 36. So 36 into 9.81 is equal to divided by 0.5 under root. So this becomes 26.58 meter per second. So this is the velocity with which the object has to be projected. 26.58 meter per second. That is the velocity of projection. Now we got now to have this to have R is equal to S, what should be the value of alpha? Now we got the value of U. Once again use this equation. You can find out S from this and then you can use that equation. Now what I will do here is, let me find out S from one of those two equations. S is the distance of the target from the initial point, that is distance, horizontal distance AB. Now substituting for U in any one of the equations. I will put in the 1. So S minus 1 is equal to U is 26.58 square of that into sin 30 divided by G. G is 9.81. Now from this you can get the value of S minus 1. So let me simplify the order test. 26.58 square into 0.5, sin 30 is 0.5 divided by 9.81, which is equal to 36. You are going to get 36 only. 36 you are going to get. So S minus 1 is 36, therefore S is equal to 36 plus 12, 48 meters. So S you got 48 meters. Once you get the value of S, now you can substitute in this once again. In this equation, R is equal to U square sin 2 alpha by G. Now what happens? R we have to find, alpha we have to find out when R is equal to S. That is, when R is equal to 48 meters, what is the value of angle of projection alpha? So substitute now. So from this, sin 2 alpha is equal to R into G divided by U square by cross multiplication. R is 48 into G is 9.81 divided by 26.858 square. And if you simplify that, so 48 into 9.81 is equal to divided by 26.58 square will be equal to 0.6665. We are getting 0.6665. So this is sin 2 alpha. Therefore 2 alpha is equal to sin inverse of 0.6665. So it will be equal to, so that is sin inverse I have to take. Sin inverse of that, which is 41.8 degrees. 41.8 degrees. Therefore alpha is half of that, that is 20.6 degrees. 20.6. That means if you project the object with an angle of 20.6 degrees, it will hit the target. That is, the range is 48 meters. The target is at a distance of 48 meters. So that also was unknown in the beginning. So only thing, by using these two conditions, one is overshot, another is it is undershot. So using those two conditions, we can find out two unknowns. One unknown is U, another unknown is S. So using those two equations, then substitute that value of S as R to get the value of alpha to hit the target. So this is how we have to do the problem on projectile motion horizontal plane. I have taken two simple problems I have explained.